Hello and welcome to the next office vlog. I may be slightly under energy here because I'm exhausted after a lot of work, so bear with me on that. But I wanted to give you an update on a project that just concluded that I'm really excited to share. So up until now, I've been using this folding table at the electronics bench. It is fine, there's just a couple of problems with it. It's really short and it's not very big. And this was never going to be a long-term solution. This was just something I already had that I could use until I was ready to take care of what needed to be done with the workbench. Now, for that, I always said I was going to buy or build something, and I came to the correct conclusion and I built something. So today, actually, let's do this. So today I want to take a look at this workbench and a couple of interesting things about it because it came out really well and it fit all my needs perfectly. So for example, one thing is that I'm on the second floor of this office and there aren't any elevators at all. So this thing had to be carried upstairs. So it comes apart into 4 pieces and then I just need to use bolts to put it back together. So I had that as a design constraint. I also needed it to be a certain width. So it is over 6 feet long actually. And it's nearly the perfect depth for stuff that we'll get into. But it's also very strong. I don't have any concerns about sitting on it, but despite what people may think, you really only need 1 2x4 per leg. So I also didn't want to make it excessively overbuilt, but one of the really cool things about this is how I designed it, because I actually used Blender as CAD software. Now, I don't mean that I just put shapes together until it was, well, the overall shape that I wanted. I actually was able to use Blender for fully parametric design with relative measurements, and I actually didn't even know what all the final sizes of all the pieces would be until it was done. So I want to cover how that works and how you could do that, and I'm actually going to give you the design file for this workbench created in Blender so that you can play around with it if you want to get some practice with parametric design, or if you just want to build one of these, which would be totally fine. So we're gonna take a look at that, but yeah, there's a lot to talk about with this thing because I have a few other tricks that I use to put it together and I'm just really excited about it. But for now, let's get back to the Blender part and show you how I designed this thing to begin with. Before I started recording, I created template objects that were MDF and 2x4s with materials that should hopefully look like what the actual thing will look like, so we'll be able to see this thing a little more clearly as I go on. The first steps that I wanted to do with this were to make a very rough example of how the whole thing would go together. So I ended up doing the standard kind of model manipulation with direct vertices and polys that you would do in Blender that really isn't that well suited to CAD, but I just wanted to get a very rough example of how all the joints and everything would go together so that I knew what I would be trying to do when I went to make it parametric. Now, some of my key design requirements were that the main vertical uprights had to touch the work surface on top, but that I also wanted the work surface to be fully supported by vertical 2x4s so that the weight would be distributed to those better. The 2x4s would then all be attached, and I wanted to also try and make sure that no ends were visible because that just doesn't look good and they're more likely to splinter and hurt. Now, another design consideration I had was to make the legs fold under the table. Now, I was kind of hoping that with the basic proportions that I wanted, that it might actually be possible to never have to remove the legs, but I wasn't sure, so I kind of did it just hoping it would work out. But as the design went on, I realized that they would be way too heavy with everything attached, and that I would have to round the corners of both the 2x4s that are supporting the tabletop and the legs, which would compromise the structural integrity. So in the end, I just kind of nixed the whole idea. But I did still need to have everything be easily detachable so that I could carry everything up into the office. Now, I didn't really need a shelf on the bottom of the workbench, but I knew I was going to have leftover material, and I wanted to have that there just for the structural support so that the legs couldn't flex in or out too much, so it kind of made sense just to add a shelf. I don't know what I will put on there. I'm thinking I may leave it empty and then just store
bits of things that I'm working on. Like say I take off the case of a computer, I could slide it under there. So hopefully it'll come in handy. I just didn't have a definitive reason to put one on there other than making the most use of the materials that I would have. After I got the basic shape in place, I decided to play around with seeing what the folding would look like before I finally gave up on that. And yeah, that just wasn't going to work out. But with the plans in place on how it would look, I was ready to start converting this to a parametric design. Now in Blender, it's not that easy to just supply variables, so what I wanted to do was create a single object that was made out of a cube that would be used to scale the full dimensions of the table. Now my initial dimensionality plan was to have it be 30 inches deep, 72 inches wide, and 36 inches tall. That way it would match my electronics bench and be deep enough for other reasons that I'll cover when I have the workbenches assembled. So what I started doing was taking apart the very rough model I had and converting everything into one unit objects, and those would allow me to set scales using drivers. Now the drivers are a way of using other variables in Blender to set the dimensions and other attributes of objects with formulas. This makes it so that you can make relative changes to objects based on the size of other objects. So, for example, I would change the size of my template cube that sets the overall dimensions, and it would automatically scale the MDF worktop that I'm showing here. Now, you can stack these and make them even more advanced. So the next thing that I did was take the vertical uprights and make them the same height as the cube, but then subtract the thickness of the worktop. That way the 2x4s wouldn't push the table up to be too tall when I went to construct it. I set the width of the shelf to be relative to the amount of excess material that I would have after cutting a 4-foot wide board. This ended up helping me in the end realize what a more efficient size would be to make the table, but I'll get to that later. I also wanted an overhang on the desk so I could clamp things to the outside, so I set a proportional overhang based off of other values that would automatically resize based on how much excess material there was, and I was actually pretty happy with that, and it worked out quite well. After that, I started moving the inner pieces that would hold up the shelves and make the legs into their full H-frame so that they would stay together. I set these based off of the scale size of the shelf in the middle. This is, again, something where I'm stacking these proportional sizes, and this is something that you can really only do when you're doing a fully parametric CAD design like this. This really helps because all of the positions and sizes of these things are just based off of that one large cube. All you are doing is providing relative offsets, and sometimes those relative offsets are based off of other things. Once I had everything proportionally aligned, I went ahead and added a little bit of Python code into a script that would automatically read the dimensions of the cube and print them to a label. This is not really well supported in Blender, but it is possible if you're persistent. But with that, I was able to go ahead and try scaling the workbench reference piece in different sizes to see what would make the most sense to build. And it really ended up being better, being slightly larger, which I wasn't expecting. So instead of making it 6 feet wide and 30 inches deep, I made it 76 inches wide and then 28 inches deep, because that made for a slightly more stable build, but also the excess material that would be left from the 8-foot long board would actually fit as a shelf in the middle if I ever decided that the shelves were actually really useful and I wanted more. So I will actually have an extra piece that I don't end up using in this video yet if I ever want to add a shelf. But that was just a little extra bit that I could do, and I didn't mind making the other changes, so it worked out well. Once I had all of the dimensions for the pieces, specifically the 2x4s, I went ahead and made a spreadsheet that I could use to add up all of the different sized lengths that I needed to cut, and then figure out how many 2x4s I could do this in. Now, to really sloppily cut these out without really planning it through, I would have needed at least 8 2x4s, and that was a little more than I knew I needed. So I ended up actually being able to cut it down by 1 to 7, and then that last one actually only got a 17-inch board cut out of it, which was kind of frustrating, but still, that was the minimum that I could get it down to because of the excess materials just not adding up. Now, building the workbench was a lot more challenging than I anticipated because I didn't have a good power miter saw, so I had to cut all of the 2x4s myself. I had the hardware store cut the MDF for me because they have much better tools for that, so I wasn't going to try and do that, but I did have to use a handsaw and a miter box to cut all of the 2x4s to length. Thankfully, out of all of the cuts, I only made one mistake, so that really wasn't that bad, and that was just because I read a tape measure upside down. But this did take a very, very long time to do. I actually have 15 hours worth of footage for the build process that was recorded in time-lapse, but that's still an hour and a half's worth of video to go through. I'm going to just cut through here and show you some of the more critical bits. So I started out by cutting all of the 2x4s, and I used my spreadsheet as a reference to mark each one. Now, one thing that is a good tip that I will recommend when you're cutting repetitive pieces like this, because each piece I was actually cutting 4 of, is that you use the first piece that you cut off as the reference for the remaining pieces. So I would go through, and each one of these, the first one I would cut, I would write the size on the board and then mark it as the alpha piece, which would be the base reference for all the other cuts. This all took quite a while to cut, as you would imagine, but then I had to decide on fasteners. Now, you may have noticed that in the design stage, I didn't actually include fasteners, and that's just because I kind of knew roughly how they would go, but I wanted to leave that to the build phase because it's a little easier to see how things will go together. Now, one thing that I had planned on here was to use T-nuts, but I'll talk a bit more about that once we get to the office again because I'm able to show them better there. This camera was just set up very quickly to record things while I was working, and I knew it was going to take a long time, and I wouldn't want to move a camera around while I was doing all this because, yeah, it just took so long. But after many hours of work and effort, I was able to get all of the different frame pieces put together and then assemble the final workbench, which was yeah, a lot of work. I'm very exhausted. It was actually 3 days worth of this that I ended up having to do. So I am pretty tired as I'm recording the video in the office because I went there the day after it was all done to get the workbench put in place.
Okay, now that you've seen the designs, I figured it'd be helpful to take a look at it in its disassembled state. And thankfully, I don't have to put too much effort into that because I like to abide by the first rule of government spending. Why build one when you can have 2 at twice the price? So there's a very good reason that I built 2 of these, and I will get into that after I put this one together. But I want to take a look at some things about the design of this in the more finished state, because I'm not able to cover everything in the CAD files because I didn't really put fasteners in that, just because I didn't want to waste the time modeling that because it gets really fiddly when you get down into that. But there's some really cool things in here. Now, the best part of this whole thing is that it's held together with bolts. Now, to do that, I used T-nuts. Now, these are flat nuts that screw to the back of the boards in here that I can then thread the bolt into, and this is so loose that I can do it by hand here. And then on this side, the legs over there have holes that will go into this position and then be held up against here. And I don't actually have to put screws through the legs to hold the table and shelf together, which means that I can easily disassemble it and carry these pieces up the stairs. Now, these aren't all particularly light. The tabletop is very heavy, and it also has this exact same frame on the bottom, so it's really not that light actually, but it's light enough that I can carry without too much effort, so it worked out well. Now, there are some other handy features on here. For example, the legs have casters, which are also mounted with the T-nuts. These casters lock in place so the wheels won't turn, which means that I can very easily move the tables around. So yeah, that will be extremely handy here because once they're assembled, they're very heavy. So really the casters were kind of needed. So yeah, now I'm going to go ahead and put this together, and you can see how long it doesn't really take. All right, now as I get started on this, I just want to mention that this ratchet with one socket is all I'm going to need to put this whole thing together because of this design, which makes it extremely easy. So I'm going to get started here. And another thing that's really nice about the way I was able to design this is because the shelf has this lip on here, and these pieces all just fit into place and are then bolted together, I can actually assemble this without needing to flip it ever. So I will be doing that because all I have to do is lift the shelf onto the legs and then press it together. Now I can just bolt it in. Okay, now to put the top on, all I have to do is just make sure I have the sides aligned correctly here. There, so the table will just pick up and slot in place. And now it just needs to be bolted in. And there we go. A second workbench. This clip took slightly longer because I had not pushed this end in as far as I needed to the first time, but this would have taken about 5 minutes to put together if I hadn't been talking and then not had that issue because I was paying attention instead of trying to record video. But now I have 2 of these, and them being on wheels is extremely beneficial. Okay, so why 2 workbenches? Well, let me get something to demonstrate. Oh, man. This is the floppy drive for my Data General Micronova. Even this, which is the lightest part of everything from the Data Generals, is 80 pounds or thereabout. And everything else is so heavy, I can't move it. This is the only part that's made it in here so far, and the current global health things that are going on have indirectly delayed the rest of it all coming in here. The camera is currently in the spot dedicated to where the Data Generals will go, so they will come in here, just not sure quite when yet. But once a part is on a work surface like this, I can't pick it up because the other ones weigh like 150 pounds and they're so tiny and so lopsided. Like the motors and the capacitors and all the electronics can be here, and there's just big empty space up front where hard drive platters sit. The platters themselves aren't that heavy because I know I have some removable platter packs, so it's all of the weight in the back. So it's like 150 pounds right here, but then there's also more stuff up front. It's just not possible to be carried easily. I need 2 people, which means that once a part is put there, I can't take it off. And dedicating a workbench that's in a very prominent position like this to just this, meaning I can't work on any other projects, is not a good idea because I don't know how long resuscitating something like this is going to take. So the 2 workbenches means that I can have one of these that can always have a Data General part on it. And then when I want to work on it in a video, I can wheel the empty workbench out of the way and then wheel the Data General specific workbench into position and film working on that. So that is why 2 workbenches, and that is also my plan on how to start finally working on Data General stuff. Now, I'm not exactly sure where the Data General workbench is gonna go as I use the other one. That's a thought that I hadn't really fully finished, so I'm not sure yet. I gotta figure that out. But this is the plan. Even if I have to push it through the door, that'll work. Speaking of that, let me talk about the dimensions of these now. Okay, I brought an example here of a vintage computer. This is the AT&T 6300. It's not even a particularly large computer, so it's a really good example of this. But I wanted to talk about the dimensions here. So my initial plans for this workbench were to have it be 6 feet wide and 30 inches deep. Now, a couple of things made that not happen. One was the parametric design process showing me that it would actually be more efficient to have this be slightly longer and slightly narrower, but that should have made it 76 inches, and it's actually 77. And also, it should have been 28 inches, but it's actually 29. So I found out that MDF boards like this are not actually sold in an 8 foot by 4 foot sheet. They are 8 foot and 1 inch and 4 foot and 1 inch. And that caught me off guard. Now, I got really lucky here because I didn't ask them to put the extra into the work surface. I had to have the hardware store cut this where I bought it, and they actually cut the shelf down here to the 20-inch width that it has, and that just happened to leave the remainder here, because if I had them cut that to 28 inches, then that one would have been 1 inch too wide and really messed up all my stuff. Now, I'm very happy that it's an inch deeper, and here's why. So this is an AT&T 6300, like I mentioned. It's not a particularly large computer. It's not very deep. But the thing about computers like this is that it's meant to have the keyboard in front of it. Now, you could put it off to the side, but what that really means is that you need all of this space to be able to use a computer like this, because you have to put the monitor on the computer itself. And this particular computer is a good example of this because the monitor is proprietary, and I couldn't just hook it up to, say, one of the other monitors here I have to test it. So it really must have its own unique monitor. Now, that is why I wanted this to be 30 inches deep, because any less and you're really crowding all of the parts here. So I'm very happy that it was at least 29. Now, this is shallower than something like an IBM 5150. So that will actually be a little deeper and crowd the keyboard, which is, I believe, also deeper itself. But 29 inches is good enough for now, so I'm happy enough with that. Now, the length of it, I didn't really have a good idea of how long I wanted it to be. I was pretty flexible on that because the reality is I want it shoved all the way up against the workbench like that, but I don't need it sticking out all the way, so I'm gonna push it in a little bit here, and that will be how it is. Now, that kind of makes this space back here unusable because I mounted the monitors in this really awesome L-shaped way, but I could just shove stuff off to there while I'm not using it. Now, yeah, that's kind of good enough. And then I'll just figure out how long I need it to be poking out. I haven't really had the opportunity to do that yet because this is the first day that they're in here, but I'm really excited about that. So yeah, that kind of covers it for these, I guess. It was a lot of work to build these. So I'm really happy that that's over because I'm tired. It's funny how much having a workbench helps to build another workbench. This is serial number 0, and this is serial number 1, I think. No, this is serial number 0, and that's serial number 1. Doesn't really matter. But another thing here about how I built these is that they aren't really precisely engineered, and I think it's actually better to build stuff like this that way. So these screws here, for example, it doesn't actually matter where they go. As long as they go through this board into that board roughly in the center, it's fine. These bolts here, they don't really matter as well. That bolt could be over there, and this one could be even there. It doesn't really matter. As long as they go through it and they pinch it together, it's good. Just eyeballing, it's fine enough. So that's why I actually had to mark these, because they'll only go in the one position. I don't need the parts to be interchangeable. Ideally, they will never be disassembled, but they will be when I inevitably move out of here for whatever reason. I have the opportunity to actually stay here for up to 9 years because I have options for my lease. So it could be a very long time before they're disassembled. I don't know. But it just is, it's easier to kind of sloppily put it together. You don't need to be hyper accurate with things like this. So that was how I built it. And that also makes it go much smoother. But there were a lot of learning things. Like if you do actually build one of these bolts have to be perfectly level. It's really a requirement, because if you don't do that with the T-nuts, which are perpendicular to the boards always, you won't go in straight and you'll cross-thread it, and that's really not good. One of the bolts on there is kind of like that, and I just left it because it only stripped it a little bit and it holds together just fine. But that is it for now. I am so looking forward to getting this done. I really wanted to use this today and try and do something. It's really not that late, but honestly, I'm exhausted after 3 days of building and heavy lifting. So I'm just gonna go home and edit the footage. And the next thing I'm gonna work on one of these is the server, which I have to replace the CPUs in. So that's kind of, well, annoying because it was problematic. But I'll get to that in the next video. Thank you to everyone who helped support the channel. I did buy a lot of the hardware for this on Amazon, and it was very expensive. People will want to know. Each one of these cost me about $200, which was, gosh, a lot of money. But I wanted to keep it a surprise on how I was doing it. So I didn't want to put anything on the Amazon wish list. There's currently nothing on there now because you all are just so amazing. But if you want to help support the channel, you can find me on Patreon or one of the other links below. But that is it for the moment. Thank you all so much, and I will see you next time.